Hi, this is part 2 of the conservation of momentum video. All right, so we're going to start with problem number 28. We've done everything else up to this point. A 3 kilogram cart moving right at 6 meters per second collides with a 2 kilogram cart moving right, so the arrows have to go to the right, at 4 meters per second. If the 2 kilogram cart moves right at 5 meters per second after the collision, find the new speed of the 3 kilogram cart. So I'm going to label them like this. So this is one, has a mass of 3 kilograms. It's moving at 6 meters per second. The other one is 2 kilograms, and it's moving right at 4 meters per second. Okay, if the 2 kilogram moves right at 5, so after they collide, here's the 2 kilograms, and it's moving right at 5 meters per second. Now the question is to figure out the velocity of the 3 kilogram object. Okay, so this is object 2. So here I'm going to write the total momentum, assuming that there is no external impulse during the collision. Okay, so the mass of 1 times the velocity of 1 plus the mass of 2 times the velocity of 2 should equal the sum of the momenta after the mass of 1, velocity of 1 after the collision, plus mass of 2, velocity of 2 after the collision. So this is just going to be 3 times 6. This is 2 times 4, so 3 times 6 plus 2 times 4. That should equal 2 times 5 plus 3 times the velocity of number 2 after the collision. And if you do the math correctly, you should get positive 5.33, which makes sense. It has to go to the right. Okay. All right, so let's look at, I'm going to actually label these objects just 1 and 2, so I don't have to redraw these pictures. Okay. So this object here is 1. Okay, so they're going to stick together, right? Moving north. So this is V1. Okay. So let's see what this is going to look like. So this guy here is not moving initially. This is 1, this is 2. This one is moving at 10 meters per second. Okay. So the momentum here is 40. You're going to do M1 V1 plus M2 V2 equals, when they stick together, they become one big mass and going at the same speed. They both go at the same speed. So this is 40 times 10, so that's 400, plus no momentum for the one that's at rest, equals okay, so we're trying to find the mass of this object 2 here. So when they stick, so they become 1 here. Okay, so here's 1, here's 2. All right, so this is 40 plus the mass of 2 times 8. Now I'm looking at north as positive, right? And if you do the math here, you should get oh, I skipped 29. So this is 30. So you should get a mass of 10 kilograms. Yeah, let's go back to 29. Okay. So this is object 2. Okay. Okay. So the momentum of the kid is M times V plus, now the sled and the other kid are not moving. It says they are at rest, so they have no momentum. This is after you write the equations, of course. Equals, now when the kid jumps in there, the mass becomes 90 kilograms times the velocity of the whole combination. So the velocity of the whole combination should be 2.5 meters per second. Let's look at 31. And again, you have to write the formulas before you answer these questions. A 5 kilogram object moving east, so I guess east is positive. So this is object 1, this is velocity 1. Connects up with a 15 kilogram object, so this is object 2, moving west. So this is V2, but you have to look at it as a negative number. What is the speed and direction of the combination? So they stick together. So we're going to do M1, V1, plus M2, velocity of 2 before the collision equals, now they become one piece, so you take the combination of their masses times the velocity of the combination after. So this is going to be 5 times 14, which is 70, plus 15 times negative 2 equals, the total mass is 20 V prime. So what is that going to be? This is 40, so it looks like a V after the stick together is just going to be 2 meters per second, and it's positive, which means the whole combination will go to the right. Yeah. Okay. Okay, let's look at number 32. Okay. Okay. So this is object 1, velocity of 1. This one is going north, this one is going south. So this has to be negative. They stick together. What's the final speed of the combination? This is kind of like similar to the previous one. So they become one piece, and they're going to have the same speed at the end. So if I look at north as positive, object 1 has a momentum of 32 kilograms meters per second. Object 2 will have 2 times negative 20 equals, when you combine them together, you get a mass of 10 kilograms. And we have to find the velocity. So this is going to be 32 minus 40, so that's negative 8 divided by 10, so negative 0.8 meters per second, which means the combination will be going south. Okay. A 300 kilogram cannon fires a 6 kilogram ball. So the cannon, we're assuming that is at rest initially. If the cannon recoils at a speed of 3 meters per second, what's the speed at which the ball moves? Okay, so before the explosion or the firing, we had no momentum. Okay, so now you can see here, since this is not, the whole system is not moving in the beginning, the momentum of the ball has to equal the momentum of the cannon. Okay. Okay, so this is going to be the mass of the ball. I guess I can call the ball 1 and the cannon 2. Okay, the cannon is 1 and the ball is 2. All right, so the mass of the cannon times the velocity of the cannon after plus the mass of the ball, the velocity of the ball after. So you can see that the only way you can get a 0 by adding these two if they are equal and opposite. So this is 300. The cannon recoils at 3, so I'm going to look at left, I guess, or the direction of the recoil as a negative, plus the mass of the ball, which is 6, velocity of the ball after. So if you do the math here, you should get 150 meters per second. You can make this a positive and you end up with a negative there. It's up to you. All right, so let's look at 34. Okay. A 35 gram, so you have to be careful here, bullet strikes a 5 kilogram stationary wooden block and embeds itself in the block. The block and the bullet fly off together at 8 meters per second. What was the original speed of the bullet? So let's try this. So it's going to be the mass I'm going to write it as, okay, mass of, so the bullet is 1 and the block is 2. The mass of the bullet times the velocity of the bullet before equals plus the mass of the block, the velocity of the block before. Now they become one piece, so that should be equal to combination of the masses times the common velocity. Okay. Now here, I don't think I mentioned this in another video, I can leave all the masses in the same, in kilograms, grams, pounds, it doesn't matter, as long as they are in the same units, because it's all proportional, right? It's all ratios here. All right, so the mass of this one is 35. We were looking for the velocity of the bullet, plus the block was not moving initially. Now the combination mass is 5,035 grams, so that's 5,000 grams and 35 for the bullet, times they move at a speed of 8.6 after. So the velocity of the bullet should be 1,237.17 meters per second. Okay, in the answer key, I turned everything into kilograms, but you don't have to. You can turn everything into grams, whatever is easier for you. Okay, let's look at 35. An 80 kilogram defensive tackle sacks the 80 kilogram quarterback who is standing still about to pass the football. With what speed do they end up moving just before they hit the ground if the tackle speed was 6 meters per second? So they become one. So you start with two terms and you end up with one at the end, right? Okay. So the momentum of this guy here, the tackle is going to be 80 times 6. The quarterback was standing still, okay, equals the momentum of the combination, which is the mass of the combination. So basically, they have a mass of 160, and you can just do the V prime, that's the velocity of the two combined, and that should be 3 meters per second. You could have done this conceptually, okay? Because basically the mass doubled, so the velocity has to be cut in half. Okay. This picture here, I think you can just look at the answers on the answer key. It's all similar to what we've been doing. So I'm going to go to something that's a little bit more complicated. Okay. A ballistic pendulum is a device used to measure the velocity of a projectile. So we're going to do this in class. So basically what you have basically a marble, okay, and you have a pendulum, okay, here, okay, and this pendulum here, there's a block here, and it's got a hole. So basically what happens is that when the ball goes inside that block, it gets stuck in there, and the pendulum swings to a different height. Basically, that's what it is. Okay, so it swings up to, let's say, here. Now this time with the ball stuck inside. Okay, and there is a certain angle here. Okay, so the mass of the bullet or the marble is 8 grams. The mass of the block is 500 grams. So I'm going to do everything in grams. Okay, so the height is 0.5 meters. Now sometimes we'll give you the angle and the length of the pendulum, and you can figure out the height, just like we did with the energy. Okay, so the way we're going to do this is that we're going to figure out the velocity of this combination. We're going to work backwards, in other words. We're going to figure out the velocity of this combination, okay, when the marble went inside the block. Then we work backwards and we do conservation of momentum to figure out the speed of the bullet, okay? So this is what we're looking for. We're looking for this V1 for the bullet or the marble. All right, so let's do conservation of energy. I can say that when you are all the way up here, this is your final state, you're going to have just gravitational potential energy because that's where the whole combination stops. And when you were down here, all the way down here, you only started with kinetic energy. Now, the mass here crosses out, but just keep in mind that if you have to use the mass, it's not going to be just the mass of the block. It's not going to be the mass of the bullet. It's going to be the mass of the combination in kilograms. Okay, but here the mass crosses out, so I think I can figure out the velocity of the combination by just doing radical 2 GH, which is radical 2 times 10 times 0.5. So this velocity here should be a radical 10, so I think it's about 3.14 or something like that. 3.16 meters per second. Now that's the velocity after this collision here, after the marble gets, or the bullet gets stuck inside that piece of wood. So now I'm going to work backwards. So this is technically the velocity after. So I'm going to do the conservation of momentum. So it's going to be 8. This is after you write the equation. V1 plus the block was not moving initially equals 508, because now they become 1, times that 3.16. Okay? And you should get the velocity to be about 200.80 meters per second. All right. Okay, we have 2 more things to do. Okay. Okay, so here I don't think we can tell. None of these are correct. And the reason for that, we don't know if they're going to stick together or not stick together. So we really don't have an idea of what's going to happen here. Okay, we don't know if they're going to stop, they're going to bounce off. We have no idea what's going to happen. All right. If they did stick together, actually, the momentum would be 0. They will stop. Okay, because you come in with 12 to the right and 12 to the left. So you basically, your total momentum is 0. So you have to end up with 0. So if they stick, they're going to come to a stop. But we really don't, nothing tells us that whether they're going to stop, bounce off each other. We don't know. Okay. All right. Okay, for this one here, so you have a bullet that's going to go through this piece of wood, and you have a bullet here, in this case, that's going to bounce. Okay. Will the speed of the wooden block after the collision be greater in case A, greater in case B, or the same in both cases? All right, it's going to be greater in case B, and we can look at this 2 different ways. The bullet experiences, when it bounces, experiences a bigger change in velocity, right? Because it changes direction. So it's a bigger change in velocity, which means the m delta v, okay, for the bullet, which is the impulse, is greater in case B, which means the impulse delivered to the block is greater because they have to experience the same impulse. It's just one is going one way, the other one is going the other way, the opposite way. So they're going to have to experience the same impulse, okay? So which means that if the block experiences more impulse in part B than it does in part A, it has to go faster. Another way we could do this is that in case A, let's say this is the initial momentum of the what do you call it? The bullet, right? After the collision, you cannot have more than this. Okay? So basically, you're going to have, this is the momentum of the bullet, and some of that momentum has to go to the block. Okay. In the second case, you started with this much momentum, but the bullet bounces, so which means it really has a negative momentum after. So the only way you can, whatever, you have to add something to this PB, okay, so that you end up with PO. Whatever you have to add has to be bigger. Okay, should have done this in. It has to be bigger by this much. So this is P for the block. So if I combine the two red arrows, the red and the blue arrow, I mean, I should end up with the black one. I think this is a little trickier of an explanation. Good. Okay. In case B, will the speed of the bullet after the collision be greater than, less than, or the same as the speed of the bullet just before the collision? Well, you started with a certain amount of energy, kinetic energy. Some of that energy has to be passed on to the block. So the bullet has to end up with less kinetic energy, right? So it has to be going slower. So the answer should be 2, basically. Okay? And I think we're done.